When you have an inductor with inductance L and resistor with resistance R and a capacitor with capacitance C, then the voltage drop for each component is that the inductor tries to counter any changes in the current. Resistance tries to counter the current itself, that's the Ohm's law. Then in here, the amount of charge is determined by capacitance times the voltage. So if you solve this for V, the voltage drop can be computed as 1 over C times Q. Just by dividing C on this side, you get 1 over C times Q, right? And because of the Kirchhoff's law, voltage loop law, usually called KVL, we see that this has to equal to 0. And just by multiplying by negative and then using the fact that the derivative of Q with respect to time, change of the charge is the current, right? So you can replace I by dq dt and di dt by the second derivative of Q, and that's how you get this differential equation. Now here we have a special case when the inductance is 1 Henry, so it's 1 times Q double prime. The resistance is 1/2 ohm, so 1/2 Q prime. And then the capacitance is 16 farads, so you have 1 over 16 Q equal to 0, whose characteristic equation would be R squared plus 1/2 R plus 1 over 16 equals to 0. And you can solve this either using factoring, or you can use the quadratic formula. Either way, you'll see that this solution just gives you negative 1/4 as the only solution. In other words, you get a double root at negative 1/4. Okay, I'm going to, just do the quadratic equation. You'll see that that's what you get. And then, because of that, you can build one solution by taking e to the negative 1/4 and put C1, and the other solution cannot be the same. The second solution cannot be the same as the first one, so what you do is you put an extra t. If this was a function of x, then you would multiply by x, but right now it's a function of t, and then you multiply C2. So that's the general solution for this differential equation. And then Q of 0, if you plug in 0, because 0 times anything is 0, you just get C1, and that has to equal to 0. And then Q prime, if C1 is 0, then you just have to differentiate this. Then Q prime would be C2t negative 1/4 times e to the negative 1/4 t, because of the chain rule, plus C2 times e to the negative 1/4 t. And again, that gives you C2 as the value of Q prime of 0, but that's equal to 4. And therefore, plugging in 0 and 4 into there, your final answer would be Q is equal to 4 times t times e to the negative 1/4 t.